All right, guys, in front of me, I got a book here. You guys listening on your drive can't see it, but on YouTube, you can see it here. It's called Feel Good Homes by Drew Tozer. Now, this book is all about heat pump applications and making a home feel comfortable, indoor air quality, all that kind of stuff. Drew's background is an energy advisor. Now he's with Foundry Heat Pumps, and he's actually giving this book away for free. PDF copy to those outside of Ontario. If you're in Ontario, he'll send you actually a hard cover, or this is a soft cover, but he'll send you the actual physical copy of the book. Now, the book there is designed for homeowners, and the foreword's written by Nate Adams, who you guys might know. It's written for homeowners to educate them on heat pumps in the process, to make it easier for the contractor coming in and giving them a quote or an assessment or something like that on their home. So there's a lot of good stuff in the conversation here between Drew and I, and we're going to get into part one of this. There is a part two, so listen to both parts because you'll get some information, and you can reach out to Drew. How you get a hold of him? We can go to foundryheatpumps.ca, so www.foundryheatpumps.ca, and Foundry spelled Foundry, foundryheatpumps.ca, and reach out to him and he can get you a copy of that book. So let's go part one with Drew Tozer. This is the HVAC Know It All podcast. I'm your host, Gary McCready. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, I'm going to read this, Drew. This is part of your book. So, you should know exactly what it says. Does your house have a room that's too hot in the summer and too cold in the winter? Do you battle moisture issues, stuffy air, or seasonal allergies? Houses are full of problems, but they're all solvable. Now, this is from the back of your book. I'll hold it up for the people watching on YouTube. This is Feel Good Homes by yourself, and pretty cool, forwarded by Nate Adams, who's been on the podcast before. So that's pretty cool. So, shameless plug for the book, but we're going to sit here and try to sell this book to people, because you've even said that you give this book away free to people all the time. And it's not about making money. It's about getting information out and promoting yourself and your company a little bit more, which I think is a cool way to do it now is with a book. So let's talk about this in a way that the technicians and engineers or professionals in the HVAC industry are listening, because you're a big heat pump guy. Right? A lot of people are like, no, heat pumps, stay away, this and that. Just give me your initial feel on the modern day heat pump. We've talked about heat pumps lots on the podcast, but it's a hot topic and everybody's got their own sort of ideas. So you give me yours.
Yeah, I think that a lot of times when people don't trust heat pumps, or they repeat kind of the myths and misconceptions about heat pumps, it's thinking about the technology from 10, 15, 20 years ago, like taking standard, not cold climate heat pumps and trying to put them in a cold climate and kind of heat a house that way. And that clearly doesn't work. But the technology's just come so far, especially in the last 5 years, for cold climate heat pumps. Most houses don't need a gas furnace for backup. Of course, that's a question of the house, the needs of the house, and also the local climate. But in broad strokes, houses, like a heat pump provides enough heating and cooling to run the house all year round. Yeah. And so that's kind of the high level general terms for heat pumps. They're good enough.
I gotta stop you at most houses don't need a gas furnace for backup. Can you please elaborate a little further? Because there's probably people jumping out of their seat right now going, Drew, what are you talking about, man?
A house doesn't care what the heat source is, right? It just wants a BTU is a BTU. It doesn't care if it's from a gas furnace or a heat pump or a propane furnace or a wood stove. It just wants enough heat. So the first big part of this is accurate heating loads, right? Figuring out how much heating a house needs and then seeing whether a heat pump by itself can cover that. So I'm in Toronto, and most houses here, the heating loads are low enough, like 2 to 3 tons at design temperature, where a heat pump is perfect for covering that. If we go to a place like Edmonton, where the heating loads are going to be higher, and you also get days that are like -40, -45 Celsius or Fahrenheit, it's the same at that point. Then it's a question of what's the heating system going to be when it's negative 40. And the answer probably isn't a heat pump by itself. The answer is probably a hybrid. So the heat pump covering most of the heating load and then having that gas or whatever combustion furnace for backup heat.
Okay. Now, there's a difference between new construction and the retrofit applications. So for myself, I mean, I've done some heat pump retrofits, some projects that we did. And these weren't, and honestly, I don't like residential. People listening to the podcast know this. I don't really like install all that much either, but I've taken on a few cool heat pump projects where I had time to install it, right? And we did the proper load calcs. We did some duct modifications. I brought in the right people to do that because I suck at sheet metal. And they were really cool projects to do from start to finish. And you learn a lot when you go through the right process of doing it rather than just showing up and flipping out a box, taking a 2-ton AC and throwing in a 2-ton heat pump and then going like this and moving on. But when you do everything right from scratch, you learn a lot of things, pretty cool things. So what I want to say about the Toronto thing, and I want to get your take on this, is that the ductwork may not be like, let's say you need 60,000. Let's say you need 5 tons of heating, right, for a home. But let's say the ductwork can only accept 2.5 tons to 3 tons when it comes to airflow, like 400 to 450. I mean, it depends where you look. Some heat pump manufacturers say, or literature says, 400 to 500 CFM per ton. Let's say your ductwork can't handle that, right? It's a big expense in a retrofit application to start ripping out duct and upsizing it, especially when it's hidden behind walls and all that kind of stuff. So what are you doing in this case when you cannot size the heat pump to the actual load of the home?
Yeah, so I think there's 3 broad situations where I like hybrids as the solution. And like all of this goes back to finding the right HVAC system for the house. It's not putting in a gas furnace in every house. It's not putting in a heat pump in every house and just forcing it and hoping it works. That's just going to lead to terrible experiences for homeowners all over the place. And then they are going to blame heat pumps for that. So the 3 scenarios that I like hybrids, one is what we just talked about for kind of Edmonton, the extremely cold climate or extremely high heating loads. The second one is what you're talking about now, which is just that there are limitations in the infrastructure of the house, which is usually ductwork or the electrical panel. And so for that scenario of we need 5 tons of heating and cooling, but we can only put in a 2-ton heat pump. Well, the solution there, if you want to go with the heat pump, is you put in a 2-ton heat pump, and then you need to have a 5-ton gas furnace for backup heat, right? Because you still need to cover that heating load no matter what. And we're not going to do that at the expense of pushing static pressure to its limits and have noisy operation, always early equipment failure, burnout fans, all of that stuff.
Yeah.
And then the third scenario is areas with that have frequent power outages. Mm-hmm. So if you're in a spot where you lose electricity all the time and you lose it for a week, it's easier to have a generator and run a furnace for backup heat rather than have a generator that covers just a heat pump by itself, especially if it's an electric heat strip for backup. So those are kind of the 3 broad scenarios where the hybrid is great.
All right, makes sense. And I totally agree with you. Now, let's say the area that we're in, I'm also in Toronto too, as you know. And I mean, in the Toronto area, like you and I are from, we have a heating load that is usually high and then a cooling load that's substantially lower. Let's say we have a 60,000 BTU heat load and only a 24,000 BTU cooling load. Now, let's say the ductwork is big enough for a 5-ton heat pump, and we put the 5-ton heat pump in to accept and do all the heating that we need. But when it comes to cooling, we're oversized now. So talk to me about that situation.
When you read the kind of the summary on the back of the book, that's the part that's talking about moisture problems, dehumidification, all of that. So when we oversize HVAC, when we oversize furnaces, it frequently leads to comfort issues, right? Because the furnace doesn't run for long enough to actually get heat to the far away rooms. By the time the thermostat is happy in the main area, the thermostat tells the furnace to turn off, and that's why the room at the top of the house, the top and the back of the house, is always too cold because it just can't match the heating needs of like it can't load match for the house. It can't provide the right amount of heating. And for ACs, that part is also true. But the other part that comes into play is the dehumidification. So when you have oversized ACs, the system doesn't run for long enough for the coil to get cold enough to actually do dehumidification. And in worst case scenario, it's so oversized that it does no dehumidification because it's just short cycling on and off. So part of finding the right HVAC system for the house is certainly keeping dehumidification in mind, which means keeping the cooling load in mind. And like the scenarios that we're talking about, I would push people to think about that as edge cases, right? Because I think we, as an industry, overestimate, especially heating loads. We overestimate heating loads, and then we think about these 60,000 BTU houses. But I go into houses all the time. Like by trade, and I'm an energy advisor. And so I was going into houses all the time and doing heat loads and doing full energy assessments for houses. And I would find that like there would be a semi-detached house in Toronto where the heating load is 1.5, 2 tons, something like that, because it's most of the house is just the neighboring house, but it would still be a 60, 70,000 BTU furnace in the house. Right. So I think that we think that it's common to have houses that are 60, 70, 80,000 BTUs. But I think most houses, more of the houses are in that kind of 2.5 to 3 tons, like the 30 to 40,000 BTU range. And so when we frame it like that, then we're talking about houses with 2.5, 3-ton heating loads and 1.5-ton cooling loads. And everything's much easier to do at that point. Like if that was the case, then the scenario you're talking about, well, then just put in a slightly go the lower end of the heating load and then just put in a 3 kilowatt heat strip to make up the difference. Because heating loads, we're just talking about the few coldest hours of the year. Like let that be little resistance top up heat. Most of it's going to cover the house for the rest of the year anyway.
Okay, so I sort of came up with a strategy, and it's not that, I mean, it's not like Albert Einstein-esque. I mean, it's basically like, so let's say you have 60,000 BTUs of heating and 2 tons of cooling, like the example that I explained. My thought process was we're going to go as high on the heating. When we size the equipment, we're going to go to as high as possible we can go with the heat or the BTUs for the heating that the current ductwork arrangement will allow. So if the ductwork arrangement allows me to go up to a 3-ton and I'm still losing out on some of that heating capacity because I'm only at a 3-ton, right? I'm at 36,000 BTUs when I need 60, but like you said, we can add in a heat strip, or if you want, you can do the dual fuel with the furnace. So would that be something, like I know that when you guys are designing your systems, is that something that you would look at as well? I mean, go as high up on the heating load as you can, but only as high as the ductwork will allow you.
Yeah, definitely. I wouldn't, in that scenario, I certainly wouldn't do the heat strip as the difference. I think a heat strip is great when it's like half a ton difference between those things, but we're not going to cover 30,000 BTUs with resistance heat. That's another way to make a homeowner angry. And also just the size of the heat strips at that point and the breaker size and all of that. But yeah, I think that's perfectly reasonable to size it based on just the largest heat pump that the ductwork can handle. The other part of this is when we're choosing equipment, homeowners, especially homeowners, always look at efficiency. They're always looking at SEER and EAR and HSPF and all of that. That's how they pick equipment. That's how they compare apples to apples. But I think that we need to push homeowners and contractors to think about the other, I think, more important performance metrics for equipment, which for me is noise and build quality, which is a little bit hard to pin down. And then dehumidification. Like different equipment is better or worse at dehumidification, and it usually comes at the expense of efficiency, right? So we don't need, for houses like this, especially when we're concerned about oversized ACs and dehumidification, then make sure that you pick equipment that is by itself better at dehumidification.
Yeah, that's especially in a humid climate. Like if you're somewhere in a drier climate, I mean, it might not be as big of a deal. But if you're like last week, I mean, it was pretty humid for us. There was a few days last week where it was even the week before, where I think it was. And sorry, my friends in the U.S., but it was like, because I'm just going by what the weather was saying. It was like 33 or 34 degrees, or at least in my area. That was the temperature at the height of the day. And then with the humidex that they added in with that moisture, that latent heat content, it was over 40 degrees Celsius in the area. So there's a lot of humidity to be pulled out of the air in this area and a lot of places as well. But I did want to bring up the fact that if we are going to do, and you brought up a good point about breaker size and all that for the electric heat strip. If the customer wants the electric heat strip, let's say they want to get rid of gas altogether, because some customers, they just want to get rid of it. Some customers don't care. You might have to upgrade the electrical panel to run the correct size heat strip. You might have to upgrade it because some of the older homes have 100 amp service and they don't have enough capacity in the electrical panel to throw in a 60 or 50 or 60 amp breaker for a 10 kilowatt heat strip. So, I mean, you got to keep that in mind too. So in that scenario, Drew, like what would you recommend? Would you, if the customer doesn't want gas, but it's going to cost them X amount to upgrade their panel, would you try to sway them into gas because it might be a more economical route in the long term? Like, how do you handle that?
The book is really around this framework that I created called HAVEN. That's just the acronym. And HAVEN, that's heating load, air leakage for the house, value mindset, environmental control, and necessary infrastructure. So the necessary infrastructure is really what we've been talking about in this podcast. That is the systems that already exist in the house, like the actual, the plumbing, the electrical, the ductwork, all of that stuff that actually makes up the house. And picking, when we're designing HVAC systems, recommending HVAC systems, it has to either work within the existing infrastructure or understand that you need to upgrade it. Like you said, upgrading ductwork is usually a no-go for retrofits just because it's such an expensive, invasive project, and there's usually a better way.
Mm-hmm.
And most of the houses that we electrify have 100 amp panels, and we go fully electric on them without needing to upgrade. I think that's another misconception, is that you need to have a 200 amp panel to go fully electric in a home. And so like the question about upgrading the panel, I think that just comes back to what's the right system for the house. And if the panel needs to be upgraded, that just goes into the decision about, do we want to go fully electric? Is there a different way we can go? Can we just go like a half ton bigger on the heat pump and still have that work within the duct work, but it means either smaller electric heat strip or no electric heat strip and just run it on the heat pump? That depends on the house. It depends on the needs of the house. It depends on the needs and goals of the homeowners, whether going fully electric and getting off gas is a priority for them. And it also really depends on the local climate for how important, how necessary the backup heat source is for the house.
In the beginning, I read that first line. It says, does your home have a room that's too hot in the summer, too cold in the winter? This is a problem in a lot of homes. In my area, or not just in my area, but I mean, lots of people call me and say, hey, like, or during conversation at like an outing or something, people find out you do HVAC. And one of the biggest things that people, they go, hey, can I ask you a question? Because you always get those, right, from people. Hey, my daughter's room is like way too cold in the winter and way too hot in the summer. And like, how can we fix that? It seems like it's a legit problem that a lot of people have, like with certain rooms in their house. And something that you said earlier can fix it just by changing the equipment to the right size equipment. We have this thing where I don't know what it is. Like, why are we throwing in 80,000 BTU furnaces when the home only needs 55,000 BTUs of heat? Like, why are we doing that? And then we are forcing way too much air through that duct. Yeah, our static pressure is too high. We are shutting off the furnace way too soon because the thermostat's in a centralized location. and that furnace runs for 5-6 minutes, the thermostat goes, yep, I'm done. So those rooms that are far away, they don't have time to receive that heat or that cooling. So when we drop the size of the machine, it takes longer for the thermostat to satisfy. During that longer period of time, and with a reduced amount of air going through the duct, reduce our static pressure. And now those rooms are actually receiving a longer run of, not a longer runtime of heating or cooling. So you tell me in your words how we solve some of these problems like that. And that's just one of the ways. It's just properly sizing the equipment from the get-go.
Yeah, so that's about load matching. That's about having your HVAC system be able to provide the amount of heating and cooling that the house needs for more hours of the year. And everyone treats HVAC like it's just about heating and cooling, and we ignore it until it's an emergency. Like we ignore the equipment until it breaks, and then it's a broken furnace in the middle of January in winter, and then you just need to get the heat back on, right? So we treat it as just about heating and cooling instead of treating HVAC replacement as an opportunity to improve the comfort, health, safety of a home and actually use it as a tool to make homes better for the people that live in them. And oversized equipment, largely because of that kind of emergency replacement mindset, where it's just about getting the heat back on as quickly and as cheaply as possible. And so if you go into a house and it has an 80,000 BTU furnace, what size equipment are you going to replace it with? You're going to replace it with a new 80,000 BTU furnace, because at least you know that that is enough heat for that house. And from a risk mitigation side aspect for a contractor, it's like you want them to have enough heat. And if it's oversized, if it's too big, it's never too small, right? And so that's kind of the mindset for contractors, is like, let's just put it in too big. So in Haven, the H is heating load, right? So that's the first part of this, is getting an accurate heat load for the house, which for me means using, I call it a performance-based heat load. So using kind of gas consumption or runtime data from a thermostat to see how the house actually performs at those cold outdoor temperatures, and using that to size the HVAC equipment for the house.
I mean, when, like I said, I've done a few projects from start to finish and doing them properly, and you learn a lot of stuff when you do that, and you're like, wow, I can't believe how much equipment is oversized out there. It's absolutely ridiculous. But I mean, you have builders doing it from day one, right? Like I don't understand why home builders are doing it when they have the opportunity to really do it right. Do you have any reasoning behind why like builders are putting in oversized equipment?
It's the same reason, right? It's risk mitigation. It's, if it's too big, it's not too small. And especially when it's new construction and it's strictly sort of a modeled heat load calculation, we end up putting safety margin on safety margin on safety margin. Like, right, we can do an accurate heat load, but then if we put a 20% margin and then we round up, and then the contractor wants to put it a little bit bigger just because they're not sure, we always end up with equipment too big. And I think more importantly in this is that we never circle back to those new construction homes to see what was the actual heat load on that house that we built 2 years ago, and we have 2 winters worth of equipment or 2 winters worth of data. We don't close that loop to see how houses actually perform. We just keep putting in the oversized equipment in kind of the next tranche of houses that they build.
Yeah, and if you think about it, if a contractor was actually smart enough, let's say they bid on a contract for 100 homes, and it's okay, it's all these homes are the same size, just to make it simple, right? Just as an example. And we're going to throw in 80,000 BTU furnaces. Well, I mean, imagine someone went in and said, you know what, I'm going to actually do a load calculation on the envelope of this home, and we're only coming out with like 55,000 BTUs of heat. So I'm going to quote this job at 60,000 BTUs. So their quote's going to be lower because they did a little bit of legwork, and they'll probably get the job because that's what these builders want. They want low cost installation, right? They want these bulk, low cost installations. And if you're going to put in a furnace that's smaller, the cost on that furnace is going to be smaller, especially if you're buying 100 of them right? And then your quote's going to be lower, and you'll probably get that job over the guy that's putting in the 80,000 BTU furnaces.